Definition of temperature. It's a measure of how much kinetic energy the particles in the material have. So it measures how fast they're moving. High temperature, a lot of kinetic energy, particles are moving fast. Low temperature, not a lot of kinetic energy, particles are moving slow. There's 3 basic scales that we use for measuring temperature. In the Celsius scale, the freezing point of water is 0 degrees. The boiling point of water is 100 degrees. In Fahrenheit, the freezing point of water is 32 degrees. The boiling point is 212 degrees. So a Fahrenheit degree is smaller than a Celsius degree. The Kelvin scale is based on the idea of absolute zero, meaning at 0 degrees Kelvin, motion ceases. There is no kinetic energy. That said, your temperatures are a lot higher. The freezing point of the Kelvin scale is 273. They don't use a degree. The boiling point is 373. Notice that a degree size on a Celsius and Kelvin scale is the same. When you go to change one temperature in one type of degree into a different temperature in a different type of degree, here's the equations you would use. Notice that the equations for Celsius and Kelvin are easy. They're just separated by 273 degrees. That's because their degree size is the same. The Celsius to Fahrenheit equations are a little more complicated because their freezing points aren't the same and because they have a difference in the size of their degrees. You have to work a little more. These are the equations you would use if you were trying to convert from one temperature scale to another. Heat energy is any energy that involves a change in temperature. We'll call that delta T. They use the letter Q to represent heat energy. Now when we talk about how does heat energy flows from areas with a lot of heat energy to areas with not a lot of heat energy, or from hot to cold. Now let's look at the equation you would use for solving for heat energy. If something's being heated or cooled, meaning there's a change in temperature going on, the equation is Q, heat, equals M, which is mass, times C, which is specific heat. It's the amount of heat that you need to change 1 gram of a substance 1 degree Celsius. Every substance has its own particular specific heat. If something has a large number for C, it's very difficult to heat or cool, like water. If something has a small value for specific heat, it's very easy to cool or heat, like most metals. And then delta T is our temperature change, and you always take the final minus the initial. So let's see if we can solve some specific heat problems. How much heat is required to heat 34 grams of water, which has a specific heat of 4.184, from 30 degrees to 85 degrees? It says how much heat, so we're solving for Q. M times C times delta T. Our mass is 34. Our specific heat is 4.184. And our temperature change. We finish at 85. We started at 30. 85 minus 30 is 55 degrees. Let's take a minute and work that out. 34 times 4.184 times 55 equals 7,824 joules. Joules is our unit of energy. Now let's try this one. How much heat is released when 1,500 grams of aluminum cools from 200 degrees to 22 degrees, and the specific heat is 0.9? Q equals the mass, which is 1,500, times the specific heat, 0.9, times our temperature change. To do our temperature change, 22 minus 200, negative 178. So let's work that out. 1,500 times 0.9 times negative 178 gives me, we'll draw it up here, negative 240,300 joules. And the reason it's negative is because it's giving off the heat. Now, obviously, Q equals M times C times delta T won't work if something's melting or freezing, because when something's melting or freezing, you stay at the same temperature. Instead of the energy going to increase the temperature, it's breaking the bonds and causing it to change from a solid to a liquid or from a liquid to a gas. So there's a different equation. And it is Q equals HF, which is called the heat of fusion, it's a constant, times the mass. Or Q equals HV, which is a constant, the heat of vaporization, times the mass. So let's try two of those. How much heat is required to melt 234 grams of ice at 0 degrees Celsius? You're melting, so you're going to use the equation Q equals HF times M. We're given HF, 333, and we know that we're melting 234. So if I work that out on my calculator, 333 times 234 equals 77, sorry I ran out of room, 922 unit joules. Try this one. How much heat is released when 545 grams of steam condenses at 100 degrees? We're condensing. Oops. So Q equals HV, which is 2,250, times our mass, 545. I think we're going to get another big number. 2250 times 545 equals 1,226,250, and our unit is a joule. Notice how much more energy you get when you have steam cooling. That's why if you get burnt by steam, it's such a bad burn, because steam gives off so much energy as it goes from the gas to the liquid, and then it's still a 100-degree liquid and it has to cool. So it's like you're getting burnt twice.